What's up, everybody? It's John and Mr. Spiny. Remember, health sucks. Let's talk about it. So what's on today's discussion, you ask? Well, we're going to be talking about the spinal pathways, doing a continuation of the central nervous system from last week's talk. So, if you would, put a picture of what this really looks like on the screen for them. So guys, what you're looking at right now is basically a transection cut of the spinal cord. So you see the dark H-shaped gray matter in the middle. That is what we call the cell bodies of the spinal cord. And then that holds nucleus and neurons and things like that we'll talk about later. And on the outside is what we're more worried about. We're worried about the white fibers. And you see, we have to know in relation to the spinal cord where the sensory tracts are and where the motor tracts are. So if you'll come back to me and look at Mr. Spiny. So we'll cut him in half, drop him down, and you'll look right on top of the central canal, looking down, you'd see it looks something like this. Maybe not the same color, but it would look similar. And what we have here is my depiction. Now you will notice I have sensory tracts on the right and motor tracts on the left. That's not how it actually looks. They are mirrored on both sides in real life, but for spatial awareness and for memory purposes, I am going to explain it like this. So for the next step, I want to explain the sensory tracts and then explain the motor tracts. All right, guys, so remember what I said. We have to know the difference between dorsal and ventral and whether it's sensory or it's motor. So the way we remember this is the mnemonic same, Dave. So what's that mean, John? Well, I'm going to tell you. Same is sensory, afferent, motor, efferent. Dorsal is afferent, and ventral is efferent. So, if dorsal is afferent, going up to the brain for sensory information, that is going to be here on the posterior side. And we know that these little bundles of fibers in the white columns, or the white commissure, is what we call funiculi or fasciculi. And these are the fasciculus gracilis in the middle on both sides, and the fasciculus cuneatus on the outsides. And this does matter because you're going to have to know the difference of what body parts or where they would be affected if, let's say, you got a cut of the spine right here compared to a cut right over here. You would have different presentations. So for the dorsal columns, what is its main function? That's what you really need to know about. Its main function as a whole is for two-point discrimination, fine touch, and vibration or proprioception, basically. So what you need to know in detail are, like, for example, on your fingertips, you have a lot of detailed proprioceptors in your lips. So all these light touch sensory organs are from the DCML. That's the main organ that's sending that information to your brain. So what is the gracilis versus cuneatus? Let me tell you that much. So if it's gracilis, what do we have? We have a gracilis muscle in our leg, don't we? So wouldn't it make sense that maybe this medial column of the gracilis would be for the lower limbs, sensory of the lower limbs? So you get a cut there, you might have problems feeling the lower limbs. And then vice versa, the cuneatus is on top of. So you stand on top of your legs. That is cuneatus, the rest of the limbs or upper body. So basically that's the dorsal column, medial lemniscus pathway. The medial lemniscus part is going to come up from the brain side, and you'll learn about that later. But for now, remember, just a basic understanding. Let's move on to the next sensory tracts you're going to have to know about, which are the spinocerebellar and the spinocerebellar. Wow, how convenient. So you have the dorsal versus the ventral. And guys, this is pretty helpful here. If you see spine, that means that's where it's probably starting from. And if you see cerebellar, that means that's probably where it's going to. So what is spinocerebellar responsible for? It is unconscious proprioception. So your ability to be able to just walk around and not have to put too much thought into it, basically. Now, dorsal versus ventral. Here's all I want you to remember. Don't learn that. Nothing. No decussations. Wink, wink. So for the second one, I want you to know ventral has how many points in the V? 2. So this is going to be called our double decussator. It's going to have 2 decussations. And then the next thing you have to know about it is that it's also going to end at the superior, since it's got two, it's more than one, it's going to end at the superior cerebellar peduncle. That's something you're going to have to know, guys, and that's it for that one. We'll move on. What's the next one? Spinal olivary. What do we know about that? Not too much, but I'm going to say spinal to the olivary tract on the medullary, and that's going to be proprioception. Sure. Move on, because we have one last one that's separated into two components, and it's a very important sensory organ. This is responsible for pain and temperature. Pain and temperature. So, which one is responsible for what? Another thing it's responsible for is going to be crude touch. So you have to know which is which. Well, ventral, the front side, is going to be for crude touch. So it's not necessarily light touch or fine touch like the DCML, where you can tell, oh, that's 2 fingers right there, or, oh no, I can't tell where that is. I can't really tell. That's more a crude touch. You can't tell how many fingers or points are being in one spot due to the orientation or how many nerves are in that area, how many bundles of those sensory organs are in that area. So that pretty much does it for the sensory organs. Ventral was crude touch, and lateral is what? If it's not crude touch, it's going to be pain or temperature. Pain or temperature. So that pretty much does it for the sensory tracts. All right, guys, so now we're ready to move on to the motor portion of the motor tracts of the spinal cord. Now, again, we talked about how sensory was afferent and motor is efferent. So it's coming from the brain down through the spinal cord. And dorsal was afferent, so we know ventral is most likely going to be efferent. And our most important efferent pathway that I'm going to talk about right now is the ventral corticospinal. And there's another one. It's called the lateral corticospinal. So this is one of the most important pathways that you have to know about. Why? Well, I'm about to tell you. For the lateral corticospinal, these are responsible for all your lateral dexterity movements of your distal extremities. So that's going to be very important if you were to suffer damage there. Also, the ventral corticospinal is for the rest of the flexors in the trunk. And that's going to be very important. If you were to damage that area there, you would compromise the efferent function of that spinal portion. So again, another thing to help you remember is within the names. So it says cortico, so it's starting in the cortex, and then it ends in the spine. That's why it's corticospinal. And that pretty much helps you differentiate whether it's going to be sensory or efferent as well. So let's move on. We talked about the corticospinals. Let's come around this way. Let's start with the rubrospinal. So I think rubro is ruby red. So that's how we remember that one. And this is for your proximal big red flexors, so your biceps and things like that. And then we have the reticulospinal formation or pathway. And if you're familiar with the reticular formation in the brain or the midbrain, which is responsible for sleep-wake cycle, then you'll remember that this one is for not just posture and your extensor muscles, but also to wake you up if you feel pain or something like that during your sleep. That brings me to my next one about pain, which is the Rubrospinal. This one wasn't in any other depictions, but I know that it's an important pathway that we need to learn about when we talk about pain modulation. So if you think anything about pain, you're most likely going to be thinking about Rubrospinal, but possibly could be talking about the reticular spinal as well. So just keep that in mind, guys. That's all I'm going to say about it. Also, we have the olivospinal, also known as the bulbal spinal. This is just, again, I'm not too big on the olivos, so we're going to say this is for another proprioceptive feedback system. Next, we have the vestibulospinal. This is a big one. If you remember the vestibulocochlear nerve, or any of those nerves that are responsible for balance, then you would know that vestibulo is for balance and postural extensors. So your next one is going to be, or the last one we have, is the tectospinal. What's very important about this one is we have something called the tectospinal reflex. So if someone were to slam the door in a classroom, or someone opens the door coming into a classroom mid-lecture, most of the class looks up. It's not because they're trying to stare at the person, it's because it's a reflex. Once you see, it's something called slim. So once you either see the light from the door opening, or you hear the sound of the door slamming or opening, your head turns based off of where the sound's coming from or where you see the light. So to give you this mnemonic, SLIM, it helps you remember on what colliculus or nucleus does this certain light or music start. So for example, S is superior colliculus, and that's for light. And then I is inferior colliculus, and that's for sound or music. And that's how you would remember that. So if you saw the light first, it'd go to the superior, and then vice versa. So that pretty much wraps it up for all of the motor tracts. The last thing we didn't cover is the laminas. And remember, the gray matter holds the nuclei, and it has, each lamina has an important or distinct feature or function. And I will get into that in just a second. But honestly, I was hoping to have someone like, you know, Dr. Tato or Troy here, but it's vacation right now, so I understand that they're not in town. But you know what? I'm going to give it a shot, and I'm just going to try to say, hey, Dr. Tato. Oh, did you hear that? Dr. Tato? What?
Well, I'm not Dr. Tato, but I can definitely help you understand the rex lamina of the gray commissure better, but I'm definitely going to need a different board. Okay, so this is much better. I'm just going to talk to you about the rex lamina like I just said. There are 10 you need to know, all labeled right here. There's only about 7 that you actually need to know. First one you really need to know is rex lamina 2. That is your substantia gelatinosa, which is substance P, which is responsible for the initiation of pain. Then we have 3 and 4. That's going to be your nucleus proprius. Moving down to 7. 7's AKA is Clark's column. This one is very big. Just remember, rex lamina 7, Clark's column. Then we're moving down to 8 and 9. 8 and 9 are located in the ventral horn. Where are we? Right here. And as John talked about earlier, that is responsible for motor actions. And in there we have our alpha and gamma motor neurons. And then moving on to 10, which is right in the middle, that's our gray commissure. You can remember that it's in the middle from commissure communicating. It's located next to the central canal, which has the CSF flow go through that. And then moving over here, we have our intramedial lateral horn. That goes from T1 to L2, and that is sympathetic innervation.
Wow. All right, guys. So I know you weren't expecting to see Dr. EA in today, and I wasn't either, but I hope you're glad to have seen a new face. So with that being said, I wanted to just do a quick recap on what that we just went over today. So guys, I know it was a lot, and to be honest with you, I did you a disservice by not going into great detail on each pathway, because this is a lot of information, and each little detail really matters. But before I get into that, let me just talk about and give you a recap. So really, how many nerves or pathways did we go over today? We went over 14 of them, and 6 of them were sensory, and about 8 of them were motor tracts. So I want you to think about the sensory, guys, and don't really remember every little detail about it. The 2 big ones you really need to know about are the DCML, and you need to know about the Spinothalamic. And if you remember their functions and you remember their names, and approximately that dorsal is, you know, sensory, and approximately ventral is motor, then you're gonna really help yourself when it comes to tests, because you don't get pictures on tests. So they're not gonna ask you what one's right here, which one's right here. No, you're gonna have to know what's the difference between rubro, reticulo, and Ralphie spinal. Those are all starts with R's. You might get confused on that on a test. So it's really, really big for you guys to just take those big key takeaways and remember this. And again, we also went over the lamina, and Erica did a pretty good job of just explaining the 7 that you truly need to know and the AKAs for them, rather than all 10 lamina, what they do. And in the future, we're gonna go into greater detail about them and talk about the synapses and the decussations or crossovers that happen there within this rex lamina. So guys, that's pretty much it. The last thing I really wanted to key in on is the ordered neurons. We didn't really talk about those. For example, I said you're gonna wanna know about the DCML and the spinothalamic. You're gonna wanna know about the ordered neurons. First order versus second order versus third order. You're gonna learn in the future that all first order neurons are in the DRG, dorsal root ganglia, as the spinal nerve comes in towards the spinal cord. So you're gonna learn about that in the future. But then you're gonna be confused when we start talking about motor tracts, and they're saying upper motor neurons versus lower motor neurons, because they're not ordered. There's not 1, 2, or 3. It's just upper motor versus lower motor. And in the future, if you're a clinician or will be, you're gonna learn about upper motor neuron lesions versus lower motor neuron lesions, and you're gonna learn a lot of orthopedic tests like the Babinski's tests and Hoffman, and all these great tests that you're gonna learn about, guys, if you stick through it. But for now, you just need to understand the functions and the basic neuroanatomy to understand in the future how you can apply it clinically. So thanks, guys. That's it. So I gotta say, if there's anything you'd like to add, please do so now. If not, I mean, just thanks, guys, for watching.
Thank you guys. We miss you, Matt.
Later.